Hey guys, welcome to question 12. So, starting with part A, we have for real numbers a and b greater than or equal to 0, prove that a plus b over 2 is greater than or equal to the square root of ab. So, this is a very common question, very popular answer. So, what we start off with is we have a difference of the two numbers, root a minus root b is all squared is greater than or equal to 0. So using this sort of identity, we can prove the answer directly. So expanding that, we have root a all squared is a minus 2 root. So root a times root b is just root ab plus root b squared is just b, greater than or equal to 0. And now you can see it is mostly just algebraic manipulation to move 2 root ab to the other side, and finally bring the 2 back over, and that will be part A. Nice and simple. Next, for part B, we have a particle is moving in a straight line with acceleration a equals 12 minus 6t. The particle starts from rest at the origin. What is the position of the particle when it reaches its maximum velocity? So from here, we are immediately given the equation. So acceleration equals 12 minus 6t. And if you guys remember, acceleration is change in velocity over change in time, or dv over dt. So using this, we can just directly integrate both the left and right hand side with dt going to the other side, and now we just have left hand side integrates to v, right hand side integrates to 12t minus 3t squared plus, let's use c1 for the sake of it. And looking at the question, the particle starts from rest at the origin. So what rest means is you just have an initial velocity of 0. So when t equals 0, v equals 0. So 0 velocity, hence 0 equals 0 plus c1. So c1 equals 0. So nothing else to add. It's just v equals 12t minus 3t squared. So next is just going to be, well, v can be written as change in position over time, or dx over dt. And we use pretty much the exact same process as before. So integrate dx and integrate 12t minus 3t squared dt. X equals 6t squared minus t cubed plus, let's use c2 for the second constant. And similarly with before, when we start at the origin, that means when your position is at 0. Hence, when t equals 0, x equals 0, so x equals 0, t equals 0, c2, and c2 is also equal to 0. Therefore, we have x equals 6t squared minus t cubed. And we wanted to find what is the position of the particle when it reaches its maximum velocity. So when is maximum velocity? Well, if you remember how to find the maximum of any sort of function, it's when its derivative is equal to 0. So when does velocity equal the maximum, well, change in velocity equals 0? Well, that's when acceleration is 0. Yeah. So a equals 12 minus 6t equals 0. So pretty easy to solve. So 6t, t equals 2. So when t equals 2 seconds, the particle reaches its maximum velocity. Hence, x equals 6 times 2 squared minus 2 cubed. That's 6 times 4, which is 24, minus a, which is 16. So the particle has a position of x equals 16 at maximum velocity. And that will be part B. Next, for part C, we have a particle with mass 1 kilogram is moving along the x-axis. Initially, the particle is at the origin and has speed u meters per second to the right. The particle experiences a resistive force of magnitude v plus 3v squared newtons, where v meters per second is the speed of the particle after t seconds. The particle is never at rest. So, first part, so CI is show that dv over dx is equal to negative 1 plus 3v. And then part 2 is hence or otherwise find x as a function of v. So, for part 1, you should hopefully remember that we have Newton's equation of force equals mass times acceleration. Now, in this case, we thankfully have a mass of 1, which makes our life easy. And what we have here is our force of magnitude v plus 3v squared. And remember, this is resistive, so this will be going against our particle. Hence, on the left-hand side, we'll have our force equals negative, because it's going against our particle, v plus 3v squared equals mass times acceleration. So, you should hopefully also know that acceleration can be written as dv over dt or v times dv over dx. So these are the two sort of equations that you can use for acceleration, and which one you use will depend on the situation. So here, obviously, we have a dv over dx, which kind of, makes it obvious we're going to be choosing v dv over dx. So mass is 1, so 1 times v dv over dx is just v dv over dx. And hopefully you guys can see, we can just take out, let me switch it around so it's easy. So v dv over dx equals negative v times 1 plus 3v. Take out dv from both sides, because v is never 0. Remember, particle is never at rest. And negative 1 plus 3v. And that will be part I. So now we are going to part 2, which is when we have hence or otherwise find x as a function of v. So we have our function, we have our first part here, which kind of already gives us dv and dx. So what I'm going to do is, first I'm going to move the 1 plus 3v over to the left side and dx to the right side. So 1 plus 3v equals integral of negative 1 dx. And from here, we will basically start integrating. So that is equal to 1/3 of ln absolute 1 plus 3v equals negative x plus c, some constant c. So, I should probably not have the equal on the first side. Now we want to find the initial sort of conditions. So when the particle is at the origin, it has speed u meters per second to the right. Hence, when x equals 0, we have v equals u. So just subbing those all in, negative 1/3 ln 1 plus 3u equals negative 0 plus c, and therefore c equals 1/3 ln 1 plus 3u. Yep, and now we just sub that in. So 1/3 c ln 1 plus 3v, 1 plus 3v equals negative x plus 1/3 ln absolute 1 plus 3u. Bit of a long one. So if we manage to pop everything together, we have, let's see, we want to bring x to the left hand side and bring this to the right hand side. so 1/3 ln absolute 1 plus 3u minus 1/3 ln absolute 1 plus 3v. And, well, using our log rules, that means that we can just put the third in front and put it all under ln absolute 1 plus 3u all over 1 plus 3v. And the cool thing is that we know that it looks like it's always going to the right, because acceleration is, well, yeah, looks like it's never just going to go to the left-hand side. So that means that we have x equals 1/3 ln 1 plus 3u over 1 plus 3v. Don't need to have the absolutes, but again, like, technically these do really mean the same thing. This is just for semantic reasons. So that will be part II, and that will be it for part C. For part D, we have using partial fractions, evaluate the integral from 2 to the n of this dx, giving your answer in the form that where f of n is a function of n. So this one's a bit of a long one, especially because you can see it is a 4 marker. So this is going to take a little bit of time. So immediately off the bat, we're going to try and break this up into partial fractions. So we have 4 plus x all over 1 minus x, 4 plus x squared is equal to some combination of a over 1 minus x plus bx plus c all over 4 plus x squared, because the first part is a linear, so we just need a, and the second one is a quadratic, so we need a bx plus c, which is also a linear on top. Hence, if we multiply both sides, so we just bring up by, times both sides by 1 minus x, 4 plus x squared, that is going to give us left side 4 plus x equals a 4 plus x squared plus, let's see, bx plus c times 1 minus x. So now we just, let's see, try to find the best ways to, now we just have to first expand each side. So that means 4a plus ax squared plus, let's see, bx minus bx squared plus c minus cx, and just factorize the right hand side, so the x squared, so a minus b x squared plus b minus c x plus 4a plus c as the constant. So we sort of line up both sides, so there's no x squared term on the left hand side, so a minus b just equals 0, b minus c, well, the x has only, it's by itself, so it's just equal to 1, and finally we have 4a plus c equals 4 as the constant. So now we just sort of sub in both sides as we want. Using equation 1, we have, let's call it 1, 2, 3. So from 1, we can say a equals to b, since a minus b equals 0. And summing it into 2, we have, therefore, a minus c is also equal to 1. And then since 4a plus c equals 4, we're just going to add these two sides. So 5a equals 5, since the negative c plus c cancel out. Therefore, a equals 1. Summing it back in, we have a equals to b. Therefore, b is also equal to 1. Finally, since 1 minus c equals 1 from part 2, summing that, we have c is equal to 0. And finally, looking at our equation up here, it was this. So we're going to sub in all our terms again. So the full partial fraction therefore becomes 4 plus x over 1 minus x times 4 plus x squared equals, so a equals 1 over 1 minus x, plus b is also 1 and c equals 0, x over 4 plus x squared. And finally, we integrate the entire thing. So integral of 2 to the n, and let's sub in our partial fraction, make our life easy, plus x squared dx, that's all in brackets, that is equal to negative ln of 1 minus x plus, let's see, 1/2 of ln absolute 4 plus x squared. And this will be from n2. So first off, we sub in n at the beginning. So that is equal to, let's see, negative ln absolute 1 minus n plus half ln absolute 4 plus n squared. Subtract, then you sub in 2. So negative ln absolute 1 minus 2 plus half ln absolute 4 plus t squared is 4. Bit of a long one, but just hopefully keeping track with me. So the negative ln absolute 1 minus n plus half ln absolute 4 plus n squared. Now, if you look at it, negative ln 1 minus 2 is negative ln of 1, which is 0. So that entire term cancels out. And half of ln 4 plus 4 is half ln 8, which is just minus ln of 8. Oof. Let's see how much more we can do. So if we try to rearrange it in this sort of equation, we have half ln f of n over 8 times n minus 1 squared. Ooh, that should hopefully give you a bit of a hint that we should be having an n minus 1 squared. So, well, what do we do there? We can say that negative ln 1 minus n is the same as negative half ln of n minus 1 whole squared. So if you remember, when you square an absolute, it's just a regular square. And when you square something, well, you can rearrange both sides. So 1 minus n, well, you can square it, becomes 1 minus n all squared, and you can just flip it around to n minus 1 squared. So plus half ln absolute 4 plus n squared. And I'm going to just make it normal brackets now, since we know 4 plus n squared is always going to be greater than 0. And minus ln 8 is going to be, oh, I nearly forgot there was a half in front. Sorry about that. Half ln 8. So minus half ln 8. Now, hopefully you guys can see that this bit is positive and these two are negative. So let's take out the halves of ln. If you take out the whole thing, that's just going to be 4 plus n squared all over 8 times n minus 1 all squared. Because that's the positive bit, so that's on top. And these are negative, so negative ln n minus 1 squared minus half ln 8. That will give us this. And therefore, we have it in this form, where f of n is a function of n, and it turns out to be 4 plus n squared. So a bit of a long one, but hopefully it wasn't too bad for you guys. And that will be it for part D. For part E, we have given the complex number z equals e to the I theta. Show that w equals z squared minus 1 over z squared plus 1 is purely imaginary. So now we take a look at, well, our w, so part E, is equal to z squared minus 1 over z squared plus 1. So we have z equals e to the I theta, so sub that in. So e to the I theta squared is just e to the 2 I theta minus 1 over e to the 2 I theta plus 1. Now we're at a bit of an impasse here, but what we can do is divide e to the I theta from everything, so all of it. So e to the 2 I theta divided, it's just e to the I theta minus e to the negative I theta over e to the I theta plus e to the negative I theta. And hopefully you guys have seen this before, but if you don't remember, so we know e to the I theta equals cos theta is I sine theta, and e to the negative I theta is equal to cos theta minus I sine theta. So if you guys can kind of see what we're going to do here, so e to the I theta minus e to the negative I theta is equal to 2I sine theta over 2 cos theta. And that's a pretty easy solve. That's just 2 over 2 is 1 I, and sine over cos is tan theta, which is purely imaginary. And that will be it for part E and question 12 overall.